So, what does it actually take to process a trillion messages every single day? Today, we're going to peek behind the curtain at Cloudflare, a company that runs a massive piece of the internet, and see the architecture that makes it all possible. And let me tell you, it's a fascinating story of solving one huge problem, only to discover you've created a completely different one.
1 trillion. Yeah, you heard that right. That's not a typo. That is the number of messages Cloudflare's internal systems need to get through every single day. And we're not just talking about people visiting websites. No, this is the digital lifeblood of their entire global network. We're talking logs, security events, performance metrics, everything that keeps the lights on. I mean, how do you even begin to wrap your head around building a system for that kind of scale? Well, before they landed on the pretty elegant solution they have now, they had to struggle with a really common problem. A problem that, honestly, anyone who's ever built software is going to recognize immediately. See, before they built the system they have today, Cloudflare, like a lot of companies, started out with a more traditional setup. But as they grew, their services started running into some major headaches. They were dealing with two massive headaches that are just incredibly common. First up, this thing called tight coupling. Just imagine a giant tangled ball of yarn where every service is directly wired into every other service. So the firewall team pushes what they think is a tiny update, and suddenly the customer billing system breaks. It made building anything new really slow and super risky. The second headache, trying to manage retries. If one service went down for even a minute, the other service that needed it had to have all this complex custom-built code just to try calling it again later. It was frankly a brittle and unreliable nightmare. So to untangle this mess, Cloudflare brought in the first hero of our story, a tool called Apache Kafka, and they've been using it in production since way back in 2014. So what in the world is Kafka? Well, the simplest way to think about it is like a central post office for data. Instead of services talking directly to each other and getting all tangled up, they just drop off their messages at the Kafka post office. Then other services can swing by and pick up their mail whenever they're ready. Okay, so here's how this new flow actually works. You have services called producers, like the firewall team, that are just creating messages and sending them off to Kafka. Kafka acts as the middleman, and it stores all these messages in these neatly organized mailboxes called topics. Then you have your consumers, say an audit system, that can subscribe to those topics and just process the messages whenever it has a free moment. And here's the magic part. The producer and the consumer are now completely decoupled. They don't even have to know the other one exists. And just like that, boom, those two massive headaches, gone. Services were decoupled, which meant teams could finally work independently without stepping on each other's toes. And if a consumer service went offline, no big deal. Kafka just holds onto its mail until it comes back. No more writing that horrible retry code. It was a total game changer. But you know how it goes in the world of engineering, right? You solve one problem, and in doing so, you often create a brand new, totally unexpected one. Their victory lap, well, it didn't last very long. I love this quote from one of the Cloudflare engineers. He said the services trying to make sense of all this data would go crazy. They were getting the messages just fine, but they had absolutely no idea how to read them. So what was going on? Well, the new problem was that Kafka is schema agnostic. That's just a fancy way of saying it doesn't care what the messages look like. It's just the mail carrier. So the onboarding team might send a customer's name as a single piece of text, like John Doe. But the firewall team might send it as two separate fields, first underscore name and last underscore name. For the poor consumer service on the other end, trying to make sense of it all, it was complete and utter chaos. So to bring some order to this data chaos, Cloudflare introduced a second key technology, our next hero, protocol buffers, or as pretty much everyone calls it, protobuf. Protobuf is basically a contract for your data. It was actually developed by Google, and it lets you define a really strict, rigid structure that every single message must follow, no exceptions. Think of it like a blueprint for your data. Now, you might be asking, hey, why not just use a common format like JSON? Well, just take a look at the difference here. Protobuf messages are way smaller and much faster for computers to process because they're in a binary format, not plain text. But for this problem, the most critical feature was that it enforces a strict schema. No more guesswork for the poor consumer. It was the absolute perfect tool for the job. Okay, so with Kafka handling the decoupling and protobuf enforcing the structure, what does the final trillion message system actually look like? Well, there was one last piece they needed to add to the puzzle. They added this final component, a schema registry.
Honestly, the best way to think of it is as a bouncer at the door of a really exclusive club. Before any message can get into a Kafka topic, the schema registry checks its ID, its data structure, against the official protobuf blueprint. If it doesn't match the rules on the list, it gets rejected. End of story.
And here it is. The whole shebang, all the pieces working together in perfect harmony. A producer creates a message. The schema registry, our bouncer, validates it. Only then is it allowed into Kafka. And finally, the consumer on the other side receives a perfectly structured message that it knows exactly how to handle every single time. This is the architecture that's both decoupled and completely reliable, even at a trillion message scale.
So, what are the big lessons we can take away from Cloudflare's journey here? First, decouple your systems. It's what lets teams move fast and innovate without breaking everything. Second, your data absolutely needs a contract. A strict schema is what prevents chaos and guarantees reliability. Third, when you get to this kind of scale, efficiency isn't just a nice to have, it's absolutely critical. And finally, and this is a big one, remember that great systems evolve. They aren't designed perfectly on day one. They're built by solving one real-world problem at a time.
You know, this is an incredibly elegant solution to a massive engineering challenge, but it leaves us with one final thought. Every solution in technology, no matter how clever, almost always creates new, unforeseen problems down the road. So as Cloudflare continues to grow beyond 1 trillion messages a day, what do you think the next bottleneck in this system will be? Thanks for watching.